After you've read everything about this, they want you to do a full-on graph, and they ask you to find any x-intercepts, any y-intercepts, any vertical asymptotes, and any horizontal asymptotes. So when we start with the x-intercepts are when y is 0. Now, f of x is just functional notation. That's the same thing as y. This is your y. And so if you stick a 0 here, if 0 equals all this stuff over here, and I'm going to actually do something a little easier. If I have 0 is equal to like 5x over 3. It's a fraction, just like that is. If I wanted to clear out my fraction, I would multiply by 3, or 3 over 1, so that this 3 cancels into itself once, and it cancels into that 3 once. Basically, you're clearing out the denominator. But what you do to one side, you have to do to the other. And when you take 3 times 0, you still have 0 over here. It's just on the right side. You're just left with the numerator. That'll happen with any fraction, even one that is as ugly as this thing. So basically, if I multiply both sides by this ugly denominator, that's going to cancel out. And what I'm going to be left with is 0 equals the x plus 4 squared times an x minus 2. And if those two things multiplied together equal 0, then that means either 0 was the x plus 4 squared, or 0 was the x minus 2. So if I were to solve this, if I took the square root of both sides here, the square root of 0 is 0, and the square root of x plus 4 squared, the square root and the squared cancel out, and I'm just left with the x plus 4. And then to solve that, I would subtract 4 on both sides. So I would get negative 4 is equal to x. That is one of my one of my x-intercepts, and it does say enter the intercepts as point a comma b. So this is going to be a negative 4 comma 0. Over here, I would just add 2 to both sides. And on this one, I get 2 is equal to x. So if the x coordinate is 2, y coordinate 0. So I'm going to type in here negative 4 comma 0 and 2 comma 0. Now, the y-intercept is when x is 0. Okay, the y-intercept, that's when x is 0. So if you put a 0 here, and a 0 there, and a 0 here, and a 0 there, and do all the math, that'll tell you where it's going to cross the y-axis. Oh, good night. Okay, let me erase all this so I have room. Let's see. Start with the numerator. 0 plus, come on, erase. 0 plus 4 is 4, and 4 squared is 16 times 0 minus 2 is a negative 2, and then 2 times 0 minus 1 is negative 1, and negative 1 squared is positive 1, and 0 times 0 minus 3 is a minus 3. Oy vey. So I get a negative 32 in the numerator and a negative 6 in the denominator. It's a negative divided by a negative, which is a positive, but 6 doesn't go into 32, but they're both even, so I can at least reduce it to 16/3. What do they want? Enter the exact answer. So I can't change that to a decimal because it's repeating. So this is going to be 0 comma 16/3. All right. And then they want the vertical asymptotes. So the vertical asymptotes, let me rewrite this. Let's see, it was f of x equals x plus 4 squared x minus 2. Now remember, the vertical asymptotes are where the denominator equals 0, but you have to see if there's any discontinuity, which there's not. An x minus 1 squared really means an x minus 1 times an x minus 1. X plus 4 squared means an x plus 4 times an x plus 4. There are no common factors in the numerator nor the denominator. So there's going to be no discontinuity. Both of these are the same, so just have to consider one of them. X equals 1, that's one of my asymptotes, and this one would be x equals 3. Let's see, separate answers using semicolons. So 1, semicolon 3, and then the vertical asymptote, oh boy. Let's see, I'll come back up here. If I were to do the numerator, if I took an x plus 4 times an x plus 4 and then took it times an x minus 2, that would end up being a 1x cubed something something something. And then the denominator, if I took an x minus 1 times an x minus 1, that end up with an x squared, but then an x squared times an x will be an x cubed. But then I have this 2 in front, so I'm going to have a 2x cubed. And since they have the same degree, the horizontal asymptote is going to be the ratio of 1 to 2. So this should be 1/2. And then they give you a multiple choice on the graph. So let's see if I can remember all this. -4, 0, and 2, 0. So -4, comma, 0, and 2, comma, 0. And then the y-intercept was 0, comma, I don't remember. Hang on. 16 thirds. Ooh, 16/3. And then the vertical asymptotes were 1 and 3, but you need a colon here. And my horizontal asymptote was, oh, I can't remember these things. 1/2, okay. 1/2. And then as you scroll down, you'll see pictures here. So, oh Lord, it's got to cross, oh, whoops, missed my 0 right there. That would have been bad. I would have gotten a red box. Don't want that. Let's see. We need to cross the x-axis at -4 and 2. -4 and 2. It looks like it's crossing there and there. -4 and 2. -2 and 4. -4 and 2. -2 and 4. Okay, so it cannot be the third one or the last one based on that. 0, 16 thirds on the y-axis. That one's crossing the y-axis at a negative something or other, so that's out. What is 16 thirds? 16 thirds. 3 goes into 16, 5 and 1/3. That looks like it might be 5 and 1/3. That's out. That might be 5 and 1/3. That's out. Okay, so we're down to the fourth one and the second one. How many were there? 1, 2, 3, 4, 5. Okay. The second one and the fourth one. Ha! And now, what am I looking for? Oh, vertical asymptotes at 1 and 3. No, that one was out. 1 and 3. Okay. And 1 and 3. Which leaves me with my horizontal asymptote, which was at 1/2. That one's at 1/2. That's at 1/2. 1/2. 1/2. It's this one. This one crosses x-axis at -4 and 2. Crosses the y-axis at 16 thirds. Vertical asymptote at 1 and 3. And horizontal asymptote at 1/2. Take a breath. Okay, I got the graph right. And I got everything else right. Woohoo! Hot diggity.